today we will be doing SOL.7.b. Some definitions you'll need to know for this are 0, which is the point of the graph where the function crosses the x-axis. Function, a relationship or expression involving one or more variable. Quadratic formula, the formula used to solve quadratic equations when the equation does not factor evenly, and you can see that right there. And imaginary solutions, which are solutions that do not touch the x-axis. Real solutions are solutions that do touch the x-axis. You understand? Good. So we're going to try one, okay? So which one of the zeros of x squared minus 5x plus 14? All right, so the first thing we're going to do so some common mistakes are factoring the equation as x minus 7 and x minus 2. If you try to factor this equation, you'll see that you can't actually factor the equation, and that's how you know that you're going to use a quadratic formula if you cannot factor the equation. So if you use, if you get the answer and you try and factor it, it turns into x minus 7 and x minus 2, or x plus 7 and x plus 2, that'll be incorrect. And also later on, when you're doing this part right here, if you use negative 5 squared instead of negative 5 squared, like negative 5 in parentheses and squared, then it'll end up being negative answer. All right. So the first thing that we're going to do is we're going to find the A, B, and C, because we're doing this formula right here. So your A would be the first variable. So right there you'd see that's x squared, and whenever there's an x, that means that in front of it there's a 1. Okay. Whenever there's a B, you see the B, what is in front of it? 5. Negative 5. Good, good. And this C, where it would be the last one that has no variable next to it, which is 14. So we're going to plug it into that equation, and like I mentioned earlier, when you put in B, you're going to want to put it in parentheses before you square it. So it'll end up being negative 5 squared minus 4 times 1 times 14. So that'll come out to 25 minus 56, which is equal to negative 31. All right. So you're going to plug your A and B and C into the equation right there, where you see a negative B, because you're going to plug in B. Since B is already negative, it's going to change to be positive. Okay. All right. So it'll be 5 plus or minus, you put the answer that we got right here, so plus or minus the square root of negative 31 over 2 and A. And A is 1, so it'd be 2 times 1. So because you cannot take the square root of a negative number, you're going to take out an I. And because 2 times 1 is 2, it'll just be 2. So the answer is 5 plus or minus I square root of 31 over 2. Do you have any questions? All right. Moving on. So here's some more definitions. So the logarithmic functions. The equation is f of x equals log a times x. Now, when you put it in your calculator, you'll see it'll give you a place to put an a. If your equation does not specifically give you an a, then you're going to put in 10. All right? Great. The next definition is exponential function, which is the inverse of the logarithmic function. All right, we're going to do another example. So what is the zero of the function? We're given f of x equals 2x plus 7 over x plus 7. So what you're going to do is you're going to plug it into your calculator, and you should get a graph that looks kind of like this. Alright. So you can see that right here, it crosses the x-axis once. So you can look at your calculator and you can figure out where it crosses the x-axis, or you can put it into your, or you can set it the number equal to, or the numerator equal to 0. So to do that, you put 2x plus 7 equals 0, because the numerator is 2x plus 7. Then to get rid of the 7, since you want to get the variable alone, you're going to subtract 7. Then to get x by itself, you're going to divide by 2, and that would give you an answer of -7 over 2. Any questions before you move on? All right, great. All right, so another one we're going to do is, what is the 0 of the function? So h of x equals log 4 in parentheses 4 minus 2x. So right there, since they didn't give us something for the a, in your calculator you would put log 10 and then put that in the parentheses. Okay. So when you plug it into the calculator, you should get a graph that looks like that. So this equation only has one place where it goes across the x-axis, which is right there. So this equation only passes the x-axis in one place, which is 3 over 2. So that's how you'd solve that problem. Pretty easy, right? Okay. All right, let's go to 7c. All right, so which is an x-intercept of the graph y equals 5 plus 2x minus 3x squared? So you're going to put it into your calculator, and you should get that. Now this is kind of different because it passes in 2 spots instead of 1, which is like right there and right there. So you can put it in your calculator and then just look at where it lands on the x-axis, or you could set the equation equal to 0. So it would be 0 equals 5 plus 2x minus 3x squared. And I usually like to flip it around, so it would be 3x squared minus 2x minus 5 equals 0. So often, like, if you look and see which 3 times -5 would be -15, and what factors equal -2, it would be -5 and plus 3. So it's going to be 3x squared minus 5x plus 3x minus 5 equals 0. So you can take an x out of both of these, so it would be x, and in parentheses it would be 3x minus 5. And this one you can't, for 3x minus 5, you can't take 1 out, so it just be, you just take 1 out. So it would be 3x minus 5. So the ones you would get is 3x minus 5 and x plus 2. And if you set those equal to 0, you'll get -1 and 5 over 3. So if your answer choices are A, which is 0, -1, B, 1, 0, C, 0, 5, D, 1, 2/3, and 0. So none of these are -1 or 5 over 3. Now obviously none of the other ones are 5 over 3, and this one's a fraction, a complex fraction, so we're going to turn it into a regular fraction. And if you multiply, it's 1, 2 over 3, so if you multiply 1 and 3, you'll get 3, and you add that to the top, so you'll get 5 over 3, which is what we got here. So the answer is D, which is 1, 2/3, 0. All right, you can go. I'll teach this to your class later. Thank you. All right. Last one. Example 1. Which statement describes the graph of gx equals x plus 2 and x squared over x squared? So if you put this into your calculator, you should get that. You can't really see it much, but it crosses the x-axis once right there. It gets really close, but it never actually touches the x-axis. And it does not cross the y-axis at all. It's still a little hard to see, but right here, these two lines never cross the x-axis. They go like this, and they keep going up. They get close, but they never touch it. All right. Any questions? Okay.
One possible real-world application for finding the zeros of equations could be shooting a basketball. You can think of the zeros of the equation as when the ball leaves the hand and when it enters the hoop.